Have you ever wondered how we were able to measure the diameter of moon? Was it measured using a measuring tape? No, it is not possible to measure such a large distance. To estimate these values, we take indirect measurements. These measurements can be anything such as congruence of figures or similarity of figures. In this video, we will try to understand what is similarity and how can it be used in daily life. But before we start, we should recap some concepts. A triangle is a figure which has 3 sides and 3 angles. The sum of all angles of a triangle are 180 degrees. We can say that two triangles are congruent if they have equal sides and angles. Let us see some congruent figures. Circles with same radii. Square with same side. Triangles with same sides and angles. Hence, we can see that all congruent figures are identical to each other. But let us see another example. Is there a relation between these two figures? Yes, you might say that both of them have the same shape but different size. This kind of relation is termed as similarity of figures. So, congruent figures have the same shape and size. Similar figures have same shape but different size. Now mathematically we need to find a relation for similarity. So let us analyze two similar figures. Here we can see that their angles are equal. Also their sides are not equal. But if we watch closely we will observe that all their sides are in the same ratio. So to define similarity, we must have two necessary conditions. Equal angles. Ratio of all sides must be equal. So a square and rectangle are not similar because they have different shape. Even though angles are equal, the ratio of their sides are different. To represent the similarity of figures, we use similar to symbol. Similarity of triangles. Now that we have defined the similarity of two figures, we can try to understand it in the case of triangles. Two triangles are similar if they have equal angles and ratio of sides is equal. Now let us try to derive a relation of two triangles. It is called basic proportionality theorem. Let us assume a triangle A, B, C in which a line parallel to side BC intersects other two sides, AB and AC at D and E, respectively. Let us join BE and CD and then draw DM perpendicular to AC and EN perpendicular to AB. Area of triangle is equal to half into base into height. So putting these formula for different triangles, we get area of triangle ADE is equal to half into AD into EN. Area of triangle BDE is equal to half into DB into EN. Area of triangle ADE is equal to half into AE into DM. Area of triangle DEC is equal to half into EC into DM. Area of triangle ADE upon area of triangle BDE is equal to AD upon DB. Area of triangle ADE upon area of triangle DEC is equal to AE upon EC. Now if we closely notice, triangle BDE and triangle DEC have the same base and against the same parallel. Hence the value of perpendicular will be equal. Hence they have equal area. Area of BDE is equal to area of DEC. Using previous results and the fact that area of BDE is equal to area of DEC, we conclude that AD upon DB equals AE upon EC. Let us see it in a triangle. Here ratio of AD upon DB is equal to AE upon EC. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. This theorem is also called Thales theorem. This has great amount of uses in mathematics. Hence, we can utilize this theorem for several cases in our real life. Let us try to solve this simple example. Here is a right triangle with DE parallel to BC. By basic proportionality theorem, AD upon DB equals AE upon EC. Putting the values and cross multiplying, the value of EC becomes 2 centimeters. We can also derive its converse theorem, which is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. This theorem can be proved by taking a line DE such that AD upon DB equals AE upon EC and assuming that DE is not parallel to BC. If DE is not parallel to BC, draw a line DE dash parallel to BC. So, AD upon DB equals AE dash upon E dash C. Therefore, AE upon EC equals AE dash upon E dash C. But this is only possible when both of these points coincide. Hence, if AD upon DB equals AE upon EC is true, then line DE is parallel to BC. Let's revise the theorem. BPT tells us if a line is parallel to base, then ratio of sides cut is equal. However, converse of BPT tells us that if a line cuts two sides of a triangle in equal ratio, then it must be parallel to the third side. Remember how we discussed the diameter of moon? Let us try to find that. Now we take a round coin and place it between our eyes and the moon. Let's say the diameter of coin is 2 centimeters. We have to make sure that it properly covers the moon. Let us use lines to represent the coin and the moon. This line represents the coin with diameter 2 centimeters. This line represents moon whose diameter we need to find out. Let us call it D. Upon setting the coin at an appropriate distance, we will be able to cover all the moon from it. This distance comes out to be 2.25 meters. From our research, we know that distance between Earth and Moon is 384,400 kilometers. Now let us visualize a triangle. For ease, we will cut the triangle into two right triangles. We take one right triangle and name it ABC. We name the points such that so that DE represents radius of coin and BC represents the radius of the moon. The coin will work as a line parallel to base. We can get the value of AE by using Pythagoras theorem. AE square equals ED square plus AD square. We get AE is equal to 2.2500222221 meters. Now using Thales theorem, we get AD upon DB equals AE upon EC. We reciprocate the terms. So now we have dB upon AD equals EC upon AE. We add 1 to both sides. We get dB plus AD upon AD equals EC plus AE upon AE, which is nothing but AB upon AD equals AC upon AE. We just need to put the values. We have values of AB, AD and AE. 38440000 upon 2.25 equals AC upon 2.2500222221. On calculations, the value of AC becomes 38 crores 44 lakhs 3,796 meters. Now to calculate the radius we use Pythagoras theorem. AC square equals AB square plus BC square. BC square equals AC square minus AB square. Putting the values, we get BC equals 1708.44 kilometers. We get radius of moon as 1708.44 kilometers. To get diameter, we double the radius. So diameter of moon equals 3416.887 kilometers. Hence Thales theorem has a wide variety of applications. Conclusion. We were able to derive and explain the application of basic proportionality theorem. We hope that you have understood the concept of basic proportionality theorem. Now, here's a secret on how you can study effectively with the Theorem app. You can learn with chapter notes, watch video lectures, and solve NCERT-based MCQ tests of this chapter on Theorem. And that's not all, you also get amazing courses for Class 10 and much more for your Class 10 preparation. Thank you.